This question is about circuits, and it's testing your understanding and your ability to understand and apply knowledge about what an ideal voltmeter would look like. So if I don't really need to do this to solve the question, but if I just sketch out a standard circuit with a couple of resistors in it, I'm not going to worry about internal resistance, but we could say this is a 6-volt supply, and then we've got two resistors, and we're interested in finding the potential difference across one of the resistors. So within this, if I'm using if I'm finding the potential difference, it's the difference in the energy on one side of the device to the other side. So it's how much energy per coulomb of charge the electrons or the charge carriers have. And I might say this power supply is set up a 6-volt difference in potential between here and here, and it would make sense for me to say this is 0 and this is 6 plus 6 volts. Anything connected with wires will be at the same potential. So this point is plus 6 volts, and this point all connected with the same wire. So this point is 0 volts as well. So if I was to connect up a voltmeter to find the difference in potential of these 2 points in the circuit, the difference between 0 and 0 is 0. So I would get no voltage if I was to put a voltmeter in here. And then if I was to attach it somewhere else, I was to attach it here, the difference between 6 and 0 is 6 volts, so I should get 6 volts. If I do the sum the other way around by changing over the terminals, then I would get negative 6 volts. Similarly, if I do that here, the difference between 0 and 6 is 6 volts, so I'll put it around negative 6 volts. And if I'm interested in what's going on in the middle, then I would need to put, if I'm interested in how much energy each coulomb of charge loses within this resistor, then I need to put the voltmeter in parallel. The voltmeter has to go in parallel because I'm having to sample two different parts of the circuit, and I'm wanting to know the difference in potential between each of these 2 points. Okay, so we get to the next part of this question. So it has to be in parallel, so it's C or D. But then do we want the resistance to be infinite, or do we want the resistance to be 0? Well, if the resistance is 0, then effectively what happens is you are doing this, and you're connecting it with a wire, and each point on a wire is at the same potential. So each point on a wire is at the same potential. So the energy will redistribute itself. The power supply will work hard to set all this to 0 volts. This will now be at 0 volts. And even if I had some magical voltmeter in here that had no resistance, it would give no reading because I've effectively short-circuited this. And now all of the energy from the power supply is being dropped across this resistor because I've short-circuited this one. So that's an extreme. What I actually want is I want the voltage at so the potential measured across here. I want the voltmeter to not influence the circuit, to influence the circuit as little as possible. Ideally, not influence it at all. So the bigger the resistance of this voltmeter, this ends up being a resistor in parallel with this device. And if the voltmeter's resistance is much, much higher than the resistance of this device, then very little current will flow through the voltmeter, and it will make very little difference to the overall resistance of this part of the circuit. If you use the equation, if I just put in some arbitrary numbers, so if I say this is say 10 ohms, then 1 over 10 ohms plus 1 over, let's go for 1 billion ohms. Well, 1 over 1 billion is a very, very small number. So if I add a tenth to 1 billion, well, that actually ends up with being roughly a tenth. You can do that calculation yourself. So actually, the overall resistance is pretty much still 10 ohms. So you want this, in theory, the ideal version would be infinite, and therefore the resistance of this part of the circuit would stay the same, so that its share of the voltage would stay the same. So you want this voltage to be as high as possible. So voltmeters need to have high resistances, whereas ammeters need to have very low resistances.